With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
See care in a new light at Madonna Rehabilitation Hospitals, where top medical minds lift you up, where the very best in specialized rehabilitation brings out your very best, where over 60 years of breakthroughs in research and technology spark your newfound strength. In our world-class hospitals, this is something greater than rehabilitation. It's renewed strength for life. Learn more at madonnarehab.org.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, this is Andrew Dunkley, and great to have your company on yet another edition of the Space Nuts podcast, episode 179, and joining me as always is astronomer at large with his sidekick Mandu somewhere lurking around under the table, Fred Watson. Hello, Fred.
Hi, Andrew. How did you know he's under the table? That's exactly
where cats go.
Yeah.
Grew up with a cat. I know all about them. We've had a few as pets over the years.
You know what they do. They like being under things.
They do. They do indeed.
He's actually going to sleep. So despite the fact that on a very recent radio interview, like about half an hour ago, he wanted to actually take it over. He just wanted to do the whole story. What he knows about high-velocity stars, I don't know, but he does. Clearly he does.
He probably knows a lot more than us collectively.
Yeah, he might do.
Now, on today's edition, we're going to be talking about an unusual gravitational effect that has proved a big benefit for galaxy observers, and they've got this pretty amazing photo from Hubble, I believe.
Yep.
We'll also be looking at a potential extension of the International Space Station mission, several years extension. I think they were going to wrap it up reasonably soon, but that may not happen, but everyone's got to agree. It's sort of like running things by a committee, really. And a couple of questions. We've got one from David in Bath. What a lovely part of the world, David. I was there last year and I enjoyed Bath very much. Didn't get to have a bath, but yeah, lovely part of the world. He's asking questions about solar eclipses and when we might not be able to see them as we do, and why Mars has massive features unlike Earth. We're a bigger planet, but, you know, our mountains and canyons are smaller than those on Mars. And we did get a question asking why. And so we'll try and tackle that. I'm just trying to remember who sent us that question. I think it was Brian from San Francisco. So we'll tackle that one for you, Brian. And plenty more. I must ask you, Fred, as we speak today, the state of New South Wales is in emergency status due to the severe weather we're experiencing at the moment. Very high temperatures, very, very hostile winds. And last I saw, we had 11 declared fire emergencies in the state. And that includes the Greater Sydney area where you are, which is under what are classified as catastrophic fire conditions. So it's been a pretty hectic day, hasn't it?
Indeed, that's right. So I'm at home kind of keeping an eye on things. Part of the reason I'm at home is to look after Mandu because if I evacuated and left him behind, I would never hear the last of it. So Mandu's okay, he's fine, and I am too. But there are fires not very far away. The nearest one at the moment is 11 kilometres away. And given that when you're downwind of one of these things, the embers can spot, I think it was 12 kilometres ahead was the record. Yes, 12 kilometres. Thank you for that. It is as you said, it's classified as catastrophic. The first time the Greater Sydney area has had that designation, and it's partly just very cold, very hot and dry winds and high temperature. And the wind is getting up as I look outside, and I can also see smoky haze in the distance. So that's in
my region, the fires aren't so much an issue for us. We're not in one of the hot spots of the state, but we are under the influence of a total fire ban. But we are heavily shrouded in dust today, and this is about the 6th dust storm we've had this season, but this one's the heaviest by far. The sky here, I don't know if you can see through my camera any of the light, but it is orange here today, and the sun is still very high in the sky, so it's a very strange looking day indeed, very eerie, and a lot of people just sort of on tenterhooks at the moment because of the conditions. So and you've got to take your hat off to the firefighters. They do an amazing job. They are working so hard at the moment, so hard.
Indeed.
Now, I know that's got nothing to do with astronomy, but I do like to keep people in touch with what's going on in our part of the world. Let's move on to this interesting question of a galaxy that you can look at 12 times because of gravitational lensing. This is fascinating, and I love the name of this one, Fred.
Do you mean PSZ1G311.65-18.48?
That'd be the one.
Yeah.
And he did that off by heart.
I did, yes. Indeed. It's, just to give the game away, why do we give these weird and wonderful names to objects like galaxies? Most of that name is the position of the galaxy in the sky, because that's almost the sort of unique identifier for an object like a galaxy. It's whereabouts in the sky it is. So that's what the name, the name refers to. The curious thing, though, is that this galaxy, as you said, has been imaged 12 times simultaneously. How can that happen? It comes about because the galaxy that we're talking about, whose name I won't read again, is 11 billion light years away. It's a long, long way off. Remember that, the sort of horizon of the universe is about 13.8 billion light years away. So we're seeing this object. It was when the universe was very young. And so its light has been traveling for a long distance. But in doing that, it's actually gone past a nearby, if I can use the term nearby, referring to something 4.6 billion light years away, a nearby cluster of galaxies. So the cluster of galaxies is basically directly in line with this distant object. And what the cluster of galaxies does is not what you'd expect, which is just block out its light altogether. Because of Einstein's general theory of relativity, the galaxy cluster acts as a lens and distorts the image of the distant galaxy. And in fact, you get all kinds of different phenomena possible depending on the geometry and the exact structure of the galaxy cluster. But what you've got here is several arcs of images of this distant galaxy. It just looks like dotted lines, basically, that are drawn on the sky, and each dot is an image of the galaxy. So there are 12 dots there, 12 copies of the galaxy, and having so many means that you've virtually got 12 different vantage points on it, and you can do all kinds of interesting analysis. And that's why we know quite a lot about this galaxy, seeing details down to, I think it was something in the region of 520 light years, which is remarkable.
Because we've talked before about gravitational lensing and the way light bounces around the universe, and it enables us to see things that happen in the deep, dark past, and we also can predict when we'll be able to see them again because of the way the light moves. So this is probably an example of that kind of phenomenon.
That's right. Actually, perhaps the most important thing that it does is lets us see things that would otherwise be invisible, because the gravitational lensing effects, just like a telescope lens, it doesn't just magnify something a long way away. It actually gathers more of the light and focuses it so that you actually see a brighter image of what the object, whatever the object is. In fact, I think the estimates in this case are that it's something like 10 to 30 times brighter than the actual galaxy. And what that does is it pushes it over the limit of visibility. It means that we can actually see this object, whereas otherwise we wouldn't be able to. It would be just too faint.
So there were 12 copies of this galaxy.
Yes, that's right.
Are they all visible to us in a single time phase? Or are we looking at them at different times in its life?
That's a really good point, because the answer is the light path for these different images is actually different in length. So that means that you are seeing them at slightly different times in the past. That actually was one of the ways back in the 1970s that people worked out that gravitational lensing was a real phenomenon. And it's because there were similar things to this, where you've got a galaxy or a cluster of galaxies distorting the light of something behind. And in this case, what it was doing, it was a distant quasar. And quasars are galaxies with a very bright core, because it's gobbling up, is the black hole in it is gobbling up all kinds of material. So, but the thing about quasars, Andrew, is that they vary in their brightness. And what was seen was, in particular, the one I'm thinking of, there's two images of the same quasar, which are separated on the sky. They've been gravitationally lensed, a bit like this one, only 2 rather than 12. And they followed the light brightened and dimmed in exactly the same way, but actually out of phase with each other, because the light path for one was longer than the light path for the other. So you saw one of them go up, and then a few days or weeks later, the other one will go up, and then the first one will go down again. A few days or weeks later, the other one will go down in its brightness, and they absolutely matched, which is what proved that what we were seeing was a gravitational lens. So your point is well made, that some of those gravitational images of this object might not be in the same time frame, which is, of course, another instructive piece of the puzzle.
So is this galaxy the one we can see the most of, literally?
I think it is, yeah. 12 separate images of it. I think it's a bit of a record, really.
I'm sure it is. And what sort of things can they glean from it? I mean, if we're looking at a single galaxy in 12 different versions over different time frames, is there something to be learned from that?
There may well be. I mean, what, of course, an astronomer would immediately think of doing would be to obtain a spectrum of each of those separate images and look at the way the details of that spectrum changes. Now, I suspect that the difference in light path that we're talking about is not really enough to see any evolutionary changes in the galaxy itself. I mean, even over hundreds of thousands of years, you might not see that when you're looking at a whole galaxy. But there could be all sorts of interesting aspects of it that might be revealed because of these multiple images.
And I think they did publish a photograph from Hubble of this. Yeah, they did. It was a Hubble NASA photo of these 12 points of light. So, and because of the intense gravity, yeah, it is quite a remarkable image, in fact. Well worth taking a look at.
Yeah, very much so. Go and have a look.
Well, if we learn anything from it in the future, we'll let you know. Not that I'll understand it, but Fred will explain it to me anyway. You're listening to Space Nuts with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Welcome back, and hello to all our Space Nuts podcast group members on Facebook. 653 people now, Fred, are talking to each other about Space Nuts. They obviously have got way too much spare time, but they're all chitter-chattering amongst each other about various astronomical things. They often pose questions. Occasionally I'll use one on the program, but they're all answering each other, which is fantastic. And what amazes me is the depth of knowledge. They're just they're quite astute people. So if you'd like to join the Space Nuts podcast group, it's on Facebook. If you're a Facebook user, just do a search for Space Nuts podcast group and join the ranks, ever-growing ranks of our little group, and have at it. Have a lot of fun. It's very worthwhile. Now, Fred, the International Space Station, it was due to be mothballed in the not-too-distant future, but now a group in the United States wants to extend its life for at least 6 years after the use-by date. And it's not an absolute guarantee because the US doesn't get absolute say in it. But why would they want to extend its life?
Oh, because they think it's still going to be useful. So just casting my mind back, I think mothball is probably the wrong term for what was intended for the International Space Station.
Let me guess, they were going to crash it?
No, it was to turn it over to the commercial sector.
Oh, it's a hotel.
Which might be the same thing. It might crash as well. But so the idea was to, end the nationally funded operations by 2024 and open it up to the commercial sector to do whatever they like with, whether that's a hotel or a factory, a zero gravity factory. Sorry, I should say a weightless factory. Those are the possibilities. But there is a very distinguished body in the U.S. legislature called the U.S. Senate's Commerce, Science and Transportation Committee. And what they are proposing, this is a lot of very learned senators, they are proposing to continue the program, as you've said, for another 6 years, up to 2030. And one of the leaders, actually, it's the chair of the Subcommittee on Aviation and Space, Senator Ted Cruz. He said, by extending the ISS through 2030, this legislation will help grow our already burgeoning space economy, fortifying the United States leadership in space, increasing American competitiveness around the world, and creating more jobs and opportunity here at home. So that's really what it's all about. There is a speculation in some of the press that it's really all about extending the space station's abilities in space manufacturing. So what you can make in space that might have different properties from if you make it in a gravity environment on Earth. That might well be some of the the motivation for this. I think the Authorization Act, which I think is what is actually being proposed, has wording that suggests that the NASA administrator shall establish a low Earth orbit commercialization program to encourage the fullest commercial use and development of space by private entities in the United States. And the Act actually goes on to ask NASA to maintain a national microgravity laboratory in space. And that's required even after the space station ceases to be a national facility. But as you said, it's not just up to the Americans, because the main partners in the ISS are Roscosmos, the Russian Federal Space Agency, ESA, the European Space Agency, and JAXA, the Japan Aerospace Exploration Agency. They're the partners that actually put the most funding into the entity, and so those agencies also have got to agree to the extension. It's not just the US going it alone.
Yeah, I mean our space agency, ASA, has a bit. We're not involved. We're brand new, so we don't get a say in it. But maybe one day we'll join that collective. I think that'd be lovely. I think we'd have to come up with a better name.
I think NASA listens to the Australian Space Agency, especially because of this funding deal that was done a couple of months ago. That the Australian Space Agency over the next, I think it's 5 years, will contribute something like $150 million to NASA, most of which actually is expected to come back to Australia, because it's all about letting contracts that hopefully will go to Australian companies.
Actually, I remember when we first announced the agencies, we were trying to think of a better name for it. I'm sure someone came up with SHASA, Southern Hemisphere Australian Space Agency or something.
Of course, yeah.
I do like that. I do like that a lot. This committee, by the way, seems to be all-powerful, because I note in an article that not only do they want to extend the life of the space station, they're also looking at influencing NASA in its next mission to the moon, which coincidentally is in 2024. At the moment, but they're talking about getting them to work on a what's described as an exploration upper stage of the Space Launch System rocket, so that it can take bigger payloads to the lunar surface.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season, because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
That's right. So the Act actually is very broad-ranging, because it also includes some scientific spacecraft. Something called WFIRST is mentioned in the Act. That's the Wide Field Infrared Survey Telescope, and the idea of travel to the moon and then ongoing travel to land humans on Mars in 2033 or 2035. That all is dictated by where Mars is in its orbit in relation to the Earth. Those are big targets, which are also covered by this committee. So it's a very interesting development. They're clearly flexing their muscles, these senators, in terms of the direction in which NASA is going, and it sounds very, very positive.
Yes, indeed. And I think I don't know if I said it to you or I said it on the radio the other day, but going back to the moon, when I was growing up and we were doing that and it was so exciting and it had us glued to the TV, it sort of died off after a while. But we've got 2 generations of humans on the planet now that weren't born when that happened.
Yeah.
And I think the excitement about going back to the moon will be restored. I think the human interest in the story will be as exciting for my children and grandchildren as it was for me and you when it happened in the 60s. So I can't wait. I think it's a great stepping stone into who knows where.
Yeah, I'm right with you there, Andrew. I think that's right.
Anyway, we will wait and see, but they're talking 2024. But we know how things in the space community, they've got to be so careful and they've got to get everything right. So it may well not be 2024, but that's their target year. So we'll watch with interest. And you are listening to the Space Nuts podcast with Andrew Dunkley and Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, a big hello to our patrons who have signed up on patreon.com/spacenuts to help support the program. We appreciate all your support. It is wonderful that you do that for us. We just think you're fantastic, and we appreciate the fact that you're willing to put a couple of dollars into the program every month. So if you would like to do that, certainly that is up to you. But it's greatly appreciated. Patreon.com/spacenuts is where you can do that. Patreon.com/spacenuts. And also a big shout out to our supporters on YouTube. We're pushing on towards 1,000. We have 622 subscribers on our YouTube channel at the moment, which is fantastic. So between all our platforms, we're getting great support, and thank you very much for doing so. Now, Fred, let's knock off a couple of questions, shall we? We've got a couple of rippers here. One from David in Bath. Hello, Fred and Andrew. I understand that the moon is gradually moving away from the Earth. That's true, David. I didn't know, but yeah, it's true. Therefore, there must come a point at which all solar eclipses will be annular eclipses, i.e. where a thin ring of the sun will always be visible. As the moon moves away, it becomes smaller to the eye and therefore doesn't cover the sun. Is it possible to work out when the last total solar eclipse will take place? Want an exact date and time, Fred, right now, off the cuff.
The answer to the question is a really interesting one. I can't give you a date because of some uncertainties, but I once did the calculation, and I got 100 million years. But in fact, the answer is much longer than that. It's probably 300 million years, and that's because it's not a linear effect. So if I remember rightly, it's 3.86 centimeters per year, the drift away of the moon. And if you just keep that going linearly for ad infinitum, then you get to the point in 100 million years where the sun. The disk of the sun is not covered by the disk of the moon ever. It's always an annular eclipse. But in fact, it's not a linear progression. The sun itself also affects the drift of the moon away from the Earth. It's the interplay of more than one set of gravitating bodies. And so when you take all those into account as well, you get something like 300 million years. So if we survive as a species that long, our distant descendants will eventually not be able to see total eclipses of the sun. And I think that's remarkable. It's a temporary phenomenon.
Yes, we're just around at the right time to witness what is an incredible phenomenon when we do have them. And as I've mentioned before, in 2028, we're going to have one of those amazing eclipses. And where I live in Dubbo, assuming I'll still be here, and I do plan to be here, we'll be in total darkness. We will almost be at the centre of totality, which will be fantastic. I'm sure it will be an amazing sight. And Sydney will be blacked out too, as Melbourne was in the 70s. And it's just one of those amazing things that we do see from time to time. I also wonder, Fred, as the moon ultimately moves away over these tens of millions of years, will it always be in Earth's control in terms of will it always orbit the Earth, or could it become like a rogue moon, or could it be captured by something else? There's a stable point that you get, and that's in billions of years rather than millions. But you get this stable situation
where the Earth and the moon are locked in this perpetual state where they sort of face each other. So the rotation of the Earth slows down, and of course we see that with the addition of leap seconds at the moment, and it slows down so that eventually the Earth's rotation becomes about 47 of our present days, and the moon takes 47 of our present days to go around once. So the moon and the Earth simply face each other. It's always the same hemispheres of each. And the distance is, if I remember rightly, it's about 500,000 kilometres, about 500,000 kilometres. So at the moment, the average distance is 384,000.
So sorry, 47 what was it?
So 47 of our present days will be the new day. That will be how long the Earth takes to rotate on its axis. And the moon will take the same length of time to revolve around the Earth. And so the two are always facing each other.
I just worked out that if that was the case, I would be 2,679 years old.
Isn't it the other way? Don't you have to divide by it rather than multiply by it?
I don't like doing it that way. No, you're right.
It means you're 29 or something good like that.
No, I'll probably still be a baby. Yeah, you're right, of course.
Yeah.
Can't slip anything past you.
Never mind, that's all right. But it's an interesting question. But yeah, so the moon doesn't just drift off into the wide blue yonder; it stabilizes at this 500,000 kilometre distance.
Okay, all right. Well, if we could sort of chuck in a billion leap year, we'd be able to see all this.
Yes, maybe.
No, somehow I don't think that'll work. We'll just have to invent time travel instead. Go and have a look and come back.
Yeah.
Okay, David, thank you. Hope that answered your question. You're going to have to wait a while. I don't think they've made calendars that far ahead yet. We will move on. This is a question that comes from Brian in San Francisco, California, about Mars. You talked recently about why its volcanoes are so big, no plate tectonics, so like all the Hawaiian chain on top of each other. What about the canyons? Why are they so deep and otherwise huge? Do we know how they were created, and are there any plans to explore them close up? Thanks. You have the best podcast on Earth. That's because it's the only one, Brian. That's what it comes down to, really. There are no other podcasts.
No. Well, it's very nice that people choose Space Nuts rather than some of the other much better ones.
Yeah. I don't know what it is, but let's not change. Let's not change.
So that's a great question, and our knowledge of the fact that Mars has these large canyons goes back to the early 1970s. It was Mariner 9, which was the orbiter that orbited Mars at that time and discovered this thing that is now called Valles Marineris. I can't even fluff this. Valles Marineris, the Mariner Valleys. And you'll note that there's more than one, because it's not just one canyon. It is huge. The main canyon is just enormous, but there's a whole system of them in roughly the same place. And they're roughly all kind of east to west as well, which is an interesting clue as to how they might have formed. So Mariner Valleys, or Valles Marineris, is a system of canyons. And the clue to how it might... Well, let me just give you the dimensions. The system is over 4,000 kilometres long. It's enormous, 2,500 miles. Widest point, 200 kilometres or 120 miles, and up to 7 kilometres deep. I mean, that is incredible, the depth. You know, when you think the Grand Canyon, if I remember rightly, is about a mile deep, which is 5,000 feet. 7 kilometres is 23,000 feet, so you're talking about something much, much deeper. However, even though it's one of the largest canyons in the solar system, I think there are some rift valleys on the Earth which are actually longer, and they probably formed in a similar way. Of course, Valles Marineris looks bigger because Mars itself is smaller than the Earth. So when you look at it on the surface of the planet, it's a gash that seems to occupy almost half the planet. Actually, if I remember rightly, I think it occupies something like a quarter of the circumference of the planet. That's true. A quarter of the planet's circumference is occupied by Valles Marineris. How did it form? Well, the clue comes from the other part of the question, which is that Mars has these huge volcanoes which got so big because they're sitting over a hotspot that never moves, or the crust of Mars never moves over the hotspot because there's no plate tectonics. So that region is called the Tharsis Bulge, or the Tharsis Rise, or Tharsis, Tharsis. And the valleys, the canyons, are actually to the east of it. So you've got this bulge and then these huge cracks in the surface right next to it and to the east of it. And so one suggestion, and I think this is a fairly recent one, is that as the crust thickened there, because of these volcanoes just constantly spewing out material, the crust thickened, and that made the crust unstable to the extent that it got this, what is called a tectonic crack. It's almost like
making a sponge cake. That's what it is.
I was going to liken it to the tectonic activity on the Earth, but a sponge cake is nearly as good, Andrew. It's nearly as good.
Well, the cake rises and splits.
And it splits, so that's right. So, in fact, the sponge cake analogy, which will be known henceforth as the Dunkley analogy for the
the Dunkley theory of Mars.
Mars, that's a better one because, that's right. As the crust of a cake rises, it splits, the sponge cake, and that's probably what's happened.
Okay.
That seems to be the general view of why it has occurred. So the two phenomena, the large volcanoes and the large canyons, are actually interrelated. They do things big on Mars. I guess it's a bit like Texas.
So if we compare Olympus Mons and the canyon on Mars to what's happening in Hawaii, do we see any of those splits in the Hawaiian Islands, or is it underwater and we can't see it?
Well, there might be, but Hawaii is different in that the crust is moving pretty rapidly actually over the hotspot in Hawaii. So the tallest volcano in Hawaii, which is 4.2 kilometers above sea level, but from the sea floor it's about 9 kilometers, might be a bit more, I think. But that's nothing compared with Olympus Mons, which is 27 kilometers and sits on top of a much thicker bit of crust. So the oceanic crust in Hawaii is relatively thin. It's probably much thinner than the crust that we're talking about on Mars. And so these cracks, whilst they might form, they don't get these gigantic proportions that we see on Mars. It's much more well-behaved in Hawaii.
Okay. So there you have it. Brian in San Francisco. Almost forgot who you were. It's all about the rise and fall, basically. The sponge cake theory. That's make yourself a sponge cake and watch it all unfold. Literally.
Watch out for the tectonic activity.
Yeah. Best experiment. Actually, speaking of school experiment, they could do that experiment at school. But I read a story today about a teacher who in 1974 unwrapped a Twinkie. Now, you said you didn't know what a Twinkie is. It's an American cake of with a soft filling, very popular. He unwrapped this is a science teacher who was trying to prove to the children in his class all about preservatives. Yep. So he unwrapped this Twinkie. Well, it's just celebrated its 47th year out of the packet, and it's still at the school on display. The only thing that's changed is its colour. It's gone from being golden to grey. Yes. But what's interesting is he's retired now, and the teacher that took over from him was one of the kids in the original class who was there when he opened the Twinkie.
There you go.
I think that's awesome. Yeah, it's got nothing to do with...
What a track record.
Yeah, nothing to do, but it's science. We talk science. But yeah, I just thought that was fascinating. And seeing we brought up Twinkies last week, I thought you'd like to hear a Twinkie story.
So there's no canyon-sized cracks in the Twinkie?
There would be, because they would have, I think they do have that across the top. So the Mars effect.
So it could be the Twinkie model as well.
Could be the Twinkie model.
One thing I didn't mention, Andrew, and just to tie up the loose end here, it looks as well as the tectonic cracks in Mars that water flow or water erosion has also played a role in growing these giant canyons, just as they have done here on Earth. So when Mars went through its warm and wet period, I think that's when there would have been erosive action, and these canyons, which were already big, presumably got even bigger.
Is it true that the Grand Canyon would fit into one of its tributaries?
I don't know.
I heard that somewhere. It might have been one of those urban myths from when I was growing up, but I'm sure it'd fit into it easily at some point.
Yeah.
All right. And thank you very much again, Brian, for your question. Hopefully we gave you an adequate answer. I've said this in the past. We're all about being adequate on Space Nuts.
I thought that was a superlative answer.
Well, until we got to the sponge cage, I think I really dragged us down there.
Yeah, it went off a bit there.
Yeah. So, one more thing before we wrap it all up. Don't forget the Space Nuts shop. It's at our website, bitez, bitez.com/space nuts. There you can buy yourself a copy of Fred's new book, Cosmic Chronicles, and a couple of his other wonderful, wonderful publications. And there's some other joker there with books as well. And T-shirts. People asked us for T-shirts, so we have provided. There are T-shirts available with the Space Nuts logo on the front. I bought one for my son for his birthday the other day, so he's now probably the only person in Sydney with a Space Nuts T-shirt, I would imagine. But yeah, why not pop along and with Christmas coming up, I mean, Christmas gift ideas are very difficult. Always someone difficult to buy for. Uncle Fred, perhaps. Anyway, yeah, pop along and have a look. And we will be back again next week. Thank you, Fred, as always.
Great pleasure, Andrew. Good to talk, and we'll look at some more stories next time.
Indeed. Professor Fred Watson, half of the packet of nuts that presents this program for you every week. And from me, Andrew Dunkley, thank you again. We'll see you on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from bitez.com.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.